Okay, so you've got a homework assignment due on Monday. That includes some of the recent stuff that we've been doing. Eric's mentioning that he's still trying to get the concrete off of his pants. You know, I feel bad for you computer science students who don't get the chance to mix up concrete, and the mechanical engineering students I don't think do that either. That's a lot of fun being out there. It was a beautiful day for mixing up concrete. So the homework's due on Monday and your project due on Friday the 20th. That's the Friday before Thanksgiving. And what we're going to do today is a different form of incremental analysis. And so the incremental analysis that we did in class on Wednesday is incremental internal rate of return analysis. And today we're going to take a look at incremental annual worth analysis. So before we begin on that, the other thing I'll mention is I sent out a template file just a couple of minutes ago. I sent out by email. So there's an Excel file that you can use as kind of the starting point for today's in-class exercise when we get to that point. Any questions related to the announcements or maybe something you've been wondering about for the project? All right. Well, you know, like I always say, if you do have questions during the weekend, you can feel free to send me an email or let's see, it looks like there's a question here. Kristen says she's lost with the project. Well, if you read through the assignment description and have any specific questions, I'd be glad to address them. And, you know, I went over pretty in depth on the day that the project was assigned. And so if you want to go back to the lecture recording for the October 2nd, that's class number 17. And so you can find that lecture recording both on Blackboard and also on YouTube. And so my suggestion, if you're feeling confused about the project, is to, you know, watch the video from the day that I assigned it, because I gave some information there, and then the assignment description itself. And then once you do both of those things, if you've got specific questions, please let me know. All right, well, today we're going to do rate of return analysis, where we look at the annual worth of items. And there are certain things that it just makes sense to consider the cost of those items on an annual basis rather than on the basis of their initial purchase price. And some of the equipment that may make sense to consider on an annual basis would be like transportation costs. And so if you're buying a car, then you may want to find out the capital recovery cost for that vehicle. And here you can see I've got a couple of laptops on the screen. And that's another thing where people will typically buy and refresh their computer equipment so often that it makes sense just to set aside a certain amount each month or each year so that you have it ready to purchase the new equipment when it's needed. So for a variety of reasons, we sometimes just want to compare alternatives on the annual worth basis. And you may remember that when it comes to annual worth, there's a built-in assumption of repeatability, and it assumes that you can get the item again for the same price if you need to repeat it. So, you know, I'll refresh your memory that there are some assumptions related to the annual worth method that we've talked about in previous lectures. But when we're comparing two different alternatives, then the question that we're going to analyze is whether it's worth it to spend more for one option versus another. And so just as a hypothetical, maybe the Lenovo computer is more expensive than the HP computer. And it may be more expensive because it has lower annual maintenance costs. It may be that it retains more of its value and therefore is going to have a better salvage value. It could be that the people are going to be more productive with that equipment for some reason. And so that the thing that we're doing in incremental analysis, same as last time on Wednesday, the question that we asked with every comparison was, is it worthwhile to spend the additional amount for the more expensive alternative? So what we'll do here is we're going to analyze the rate of return on the additional investment when we compare the annual worths. And so what we'll do in order to solve for that unknown interest rate is we're going to find what is the interest rate that makes the annual worths of the two options equal to each other. All right, so what we'll do is we'll just jump straight into the in-class exercise because I think that's the most effective way to illustrate the procedure and kind of the underlying ideas here. And the in-class exercise setup that we're going to consider is what if we had a bobcat front-end loader and a caterpillar front-end loader. And we know the initial cost for both of these items. We know their annual operation and maintenance costs. So you see that for both of the alternatives. One of the options lasts longer than the other. They have differing salvage values. And so what we're going to do in this in-class exercise is we're going to use this template file that I sent out, and there's a procedure, a step-by-step procedure that is going to allow us to find the difference in the annual cost between them, and then solve for the interest rate that makes the annual costs the same. Okay, so this is what the in-class exercise paper looks like that if you've printed those out earlier in the semester, it'll look like this. So we've got option A and option B. And you can see that in the calculation method, we start with a guess value for the unknown incremental rate of return. So if you've got this template file, you can go to that. Let me see if I can size these windows so that we're able to see both the in-class exercise and also the template file at the same time. All right. That'll do, I think. Okay. So we start off with an initial guess value for delta I star. And by the way, what delta I star means is we want to find out, is it worthwhile to get the more expensive alternative? So the two options are option A is 8,000, option B is 13,000. So we want to know, based on an annual worth analysis, how much this extra $5,000 that it costs to purchase option B is going to return. So we want to know the rate of return on the difference between the price. All right, now I've given you some step-by-step procedure here. Rather than doing it, I want to give you some time to try and interpret these instructions along with the template file that you've already been emailed. And then after a few minutes for you to work through these instructions, what I'll do is I'll break in and demonstrate and see if we're all on the same page. Please note at the bottom here that I suggest that you fill in the blanks on the paper. And that's just so that if you come back to it later on, if you've got these printed out, you kind of refresh in your memory what the values were, because if you keep changing the interest rate, then the spreadsheet values are going to be constantly changing. So there's also the secondary question at the bottom that if you choose option A or an option B, you know, you've got the choice, which one should you select? If your rate of return is 9%, should you buy the more expensive alternative or should you get the cheaper alternative? All right. So I'll pause for now and you work through the process of figuring out from these instructions how to fill in the template file. Okay, now if you're still working on this, you can continue. I'm not going to narrate through as I set up the solution, but I'll put it onto the screen in case you're stuck on something. You can watch it what I'm doing, and hopefully that will spark an idea of what you should do as well. Anybody else get 12.65%? Good. All right. So now let's go through it together. At first, we don't know what the incremental rate of return is. And so we just have to start with a guess value. So I started with 1% as the guess value. So putting in the lifespan, that's pretty self-explanatory, but one thing I'll point out is that down at the bottom, we're going to find the combined annual cost. And so that means that we have, in this case, both costs and revenues. So the way we can handle that is either to put the minus sign with the numbers that are related to cost, and then add the terms together. So you see I'm saying that's x plus y plus z. Excuse me. So that's one way to differentiate between the revenues, which are positive, and the costs that are negative. Or we could have just, cost already implies that that's an outflow. And so we could have changed this formula to say that it was x plus y minus z. And then the costs would just be the absolute value of how much outflow you have. So whichever way is fine, but we just have to make sure to differentiate between costs and then this item Z was salvage value, which is income. Okay, so the function that I use to find the annual equivalent is the payment function. And so let me talk through again how I did that. So the payment function we say equals PMT. And what the payment function does is it's find A given either a present value or a future value. So remember, if you're thinking about the factors that you could put into a paper solution, you would be thinking if you know the initial cost and you want to find the annual equivalent, that's find A given P. And so here, the way that Excel handles a find A given P is with the PMT function. So once we put that parentheses in, it begins to give us prompts below the formula of what it needs to see in order to do its calculation. Harry asks for option B, why isn't the annual cost $1,900? Yes, but let's see. You're talking about here? Let's refresh our memory. What did it say? $1,900 less per year to operate. So it's the annual cost of A is $3,500 and option B is $1,900 less than that. That's all right. Happens to the best of us. All right, so back to the payment function. So equals PMT. Now we tell it the rate. We don't know what the rate is. We're just going to click up here into the location. Now NPER, that's saying over how many years do you want to annualize the initial cost. So that's the N value in this function. So I'll just click up here on the number of years, comma. Now the remaining options is either the amount we're going to put in will be known as a present value or a future value, or you can put in both. If you put in both, this payment function is essentially performing the capital recovery calculations where you have a cost and a salvage value, and so you can have both a present value and a future value, but here we just are annualizing the initial cost. So that's a present value, and I'll put the minus sign into the function because otherwise it would flip the sign of that for us in an unwanted way. So now $844 every year is an equivalent amount when it's 1% compounding, starting with a future value, starting with a present value of 8,000. So 8,000 now is the same as 10 annual amounts of $844 if we're talking about 1%. Okay, the annual costs are given and known. The salvage value is 0 versus 2,000, and then we have to do the payment function again on the salvage values, but this time it's not a present value. That's 0, so let me not do it on that. This one's more interesting since it actually has a salvage value. So let's look at the payment function again, equals PMT. So we're clicking up here to the guess interest rate. N is going to be 5 years because that's the N value for option B. And the salvage occurs at the end of the 5-year period, not at the beginning. And so we have to skip over the present value field and put minus of the salvage value as the amount inside of the future value. So closing that, then it finds the equivalent, $392 every year for 5 years is the same as a one-time lump sum of $2,000 at the end of the 5-year period. Okay, so then the 3 components of the cost is the initial, which has been annualized, the operating expenses, which already were annualized, and then the salvage value annualization. Combining the 3 together, then at 1%, option B is less costly. So if you have 1% interest rate, option B is going to be less expensive on a year-by-year basis. What if you have 20% interest? So 0.2. So at 20% interest, option A is better. So which option to choose, whether to go for option A versus option B, that's going to flip based on what interest rate is applicable. So if we want to find the rate of return on the difference in cost, then what we're looking for is we want to find what delta I star gives us a 0 difference between the 2 options. And so it's balance. Remember, internal rate of return, we're finding the equivalence between the 2 options. And so we want to find the rate of return on the difference between them. So that'll make the rate, the unknown interest rate is where the difference is 0. So in order to do it in an automated way rather than manually just typing in numbers over and over, we can go here to the Data tab, What If Analysis, Goal Seek, and now our goal is to set the difference to a value of 0, and then it should do that by changing the interest rate. So you click OK. It runs through it. It finds convergence. There's 0 difference, and it did that with 12.65%. So that means that if you get option B, it's more expensive, but it has lower costs, and the rate of return is 12.65%. And so now think about this question at the bottom. You must choose option A or option B. If your MAR is 9%, which alternative is best? Well, the decision criteria for incremental annual worth analysis is similar to the decision criteria we've used in other types of analysis. And so since the rate of return is greater than the minimum, that tells us we should choose the more expensive alternative. And that's the same thing that you did in incremental analysis on Wednesday. If the rate of return was bigger than the MAR, then that means between the 2 options, choose the more expensive one. And so the way to think about it is that if you're borrowing money for 9%, but you can earn a return on that money of 12.65%, then you should definitely go ahead and do that. It's better to borrow money at a low price and do something with it that returns more than the borrowing cost. So the answer is choose option B. So let's put that into the spreadsheet. All right, so we say which option to select and why. Mentioning the decision criteria specifically is good custom. Makes clear that not only do you know how to find the internal rate of return on the difference, but also you know how to interpret and make the decision based on that analysis. So option B is better. Any questions about this method? Wow, I don't think we finished this early before, but I guess the weekend starts early. If you do have any questions related to the homework or related to the project, feel free to give me a call on Teams. I'm just going to be sitting here at my desk for the next few minutes, so get in touch if I can help. Let's take a look at the announcements. Remember that the homework assignment number 8, that's due on Monday. All right, that's it. Take care.